Multiplying multi-digit numbers. When multiplying larger numbers, it is usually easier to write the numbers vertically, lining up the digits in columns by place value. As a reminder, place value means the value of a digit based on its position in the number. Numbers require assigned seating. In the number 34, the 3 is in the tens place and means 30, while the 4 is in the ones place and means 4. So now let's multiply 46 times 3. We write 46 on top and 3 underneath the ones digit. It will become clearer later why writing the number with fewer digits on the bottom is useful. We start in the ones place. And the ones digit of 46 is 6, so we multiply 3 times 6. That equals 18. Since 18 has 1 10 and 8 ones, we write the 8 in the ones place of the answer and carry the 110 above the tens place. Now we multiply the tens digit. The tens digit of 46 is 4, so we multiply 3 times 4 equals 12. Then we add the 1 that we carried. That gives us 13. We write 13 in front of the 8, giving 138. So 46 times 3 equals 138. The carrying step is really place value in action. When 3 times 6 gives 18, we cannot put both digits in the ones place. The 8 belongs in the ones place, and the 1 represents 110, so it moves to the tens place. This is a good place to slow down and notice that multiplication is not only about memorizing facts. It is also about carefully managing place value. The digits you write down must go into the correct places, or the answer will not represent the correct number. The same process works when the top number has 3 or more digits. You still multiply from right to left, starting with the ones place, then the tens place, and then the hundreds place, and so on. When the bottom number has 2 or more digits, we multiply by each digit separately. Each result is called a partial product. A partial product is one part of the final multiplication result. After finding all the partial products, we add them together. Let's multiply 54 times 26. We write the numbers vertically with 54 on top and 26 underneath. First, we multiply by the ones digit of the bottom number. That's this one. So we multiply 54 times 6. We calculate 6 times 4 equals 24. We write the 4 and carry the 2. Then 6 times 5 equals 30, and 30 plus 2 is 32. The first partial product is 324. Now we multiply by the tens digit of the bottom number. The tens digit of 26 is 2, but because it is in the tens place, it really means 20. So we're multiplying 54 by 20, not just 54 by 2. This is why we write a 0 as a placeholder in the ones place before beginning the second partial product. That's this guy. Then we calculate 2 times 4 is 8, 2 times 5 is 10, giving 1080 as the second partial product. Finally, we add the partial products. 324 plus 1080 equals 1404. So 54 times 26 equals 1404. The placeholder 0 is important because it keeps the place values lined up correctly. Without the 0, the second partial product would accidentally be treated as ones and tens instead of tens and hundreds. These zeros don't change the basic fact, they just move everything into a fancier neighborhood. The same partial product method still works when there are 3 or more digits. The only difference is that there are more partial products and there are more placeholder zeros required. Let's multiply 2,430 by 512. We write 2430 on top and 512 underneath because the amount of digits in the bottom number dictates how many partial products we will have to add together. Since 512 has 3 digits, we will have 3 partial products. one for multiplying by 2, one for multiplying by 1/10, and one for multiplying by 5/100. Right? So hopefully that makes sense that if we reverse these, we would have more partial products to add up. So we want to give ourselves less work. So first we multiply 2430 by 2, which gives us 4860. Next, we multiply by the tens digit. Since the 1 is in the tens place, it means 10. So this partial product is 2430 by 10, which equals 24,300. That is our placeholder 0. This one just happens to be 0 because 1 times 0 equals 0. We write the product starting in the tens place, or we use 10 as a placeholder. Next, we multiply by the hundreds digit 5. Since 5 is in the hundreds place, it means 500, which means this one gets 2 placeholder zeros. This number just happens to be 0 because 5 times 0 equals 0. Now we add the partial products. 4,860 plus 24,300 plus 1,215,000 equals 1,244,160. The most common mistake in this kind of problem is not the multiplication fact itself. It is misaligning the partial products. Each partial product must begin in the place value of the digit being used from the bottom number.